Welcome to This Explainer. Look, if you've ever listened in on a deep dive discussion between a couple of senior cloud architects, usually right after a completely grueling 3 a.m. pager duty alert, you know exactly the transition we're obsessing over today. We're talking about why shifting to microservices in Kubernetes essentially makes traditional monitoring totally obsolete, and why cloud-native observability is the absolute mandatory path forward. We're going to unpack the architecture, the tooling, and the site reliability engineering practices you need to actually keep modern distributed systems running smoothly.
Here's our roadmap for building resilient enterprise platforms. We'll start with 1, beyond traditional monitoring, then move into 2, defining system observability. Cover 3, the 3 essential pillars, look at 4, the observability toolchain, apply it to 5, empowering SRE practices, and finally wrap up with 6, building your enterprise platform. All right, let's jump right in.
So, 1, beyond traditional monitoring. We really have to acknowledge the core architectural pain point driving this whole industry shift. Dramatic increases in system complexity demand an entirely new approach.
The crucial point of departure here is this. Monitoring is simply a binary alert of failure, while observability gives you the deep diagnostic context you actually need for complex distributed systems. Think back to a legacy monolithic LAMP stack architecture. In that world, checking if a single database or application server was just up or down was usually enough, right? If it crashed, you just restarted it. But today, we're adopting microservices, Kubernetes, serverless functions. The number of moving parts has literally exploded. In a modern distributed architecture, a user checkout failure isn't just a down server anymore. It's a cascading timeout across 40 different microservices spanning multiple availability zones. Knowing that a service crashed, which is exactly what monitoring tells you, is just step 1. You need to know why it crashed and where the fire actually started. Was it a memory leak in a specific container? A massive spike in latency from some third-party downstream dependency? Or maybe a bad configuration deployed 5 minutes ago? Observability is the practice that gives you that rich context required to answer those incredibly complex needle-in-a-haystack questions.
Let's move to 2, defining system observability, and look at what this modern capability actually entails from a pure engineering perspective.
You can't fix what you can't see. This perfectly encapsulates our entire mission here. Blind spots in a cloud-native architecture are, without a doubt, the ultimate enemy of reliability. Think about the very nature of ephemeral Kubernetes pods. They're designed to spin up, process a workload, and then just terminate in a matter of minutes or sometimes seconds. If a failure happens, let's say a pod gets OM killed, meaning it ran out of memory and the system destroyed it, and you didn't ship those logs and metrics off the node before it vanished, well, congratulations, you are now a paranormal investigator trying to troubleshoot a ghost. That incident is effectively invisible to your engineering team. You simply cannot fix what you cannot see.
So observability is defined as the ability to understand the internal state of a system by analyzing the data it produces. In other words, we have to architect our platforms to emit the right external signals so we can accurately infer their internal health. And it's vital to understand that observability isn't just a shiny tool you buy off a vendor's shelf. It's fundamentally a property of the system itself. As cloud architects and platform engineers, we have to design our applications to continuously broadcast high-quality telemetry about what they're doing, how long it's taking, and what errors they're hitting. Notice I said high quality. Emitting garbage data isn't observability, it's just noise. The real challenge here is managing high cardinality data, meaning data with lots of highly specific, unique attributes, ensuring that when your systems broadcast their health, the data is actually searchable, structured, and genuinely useful for debugging.
Okay, on to 3. The 3 essential pillars. To achieve this level of internal visibility, we really rely on 3 distinct types of telemetry data.
Let's trace the macro view of this entire telemetry pipeline. The journey begins on the far left, right at your application code. From there, we extract the 3 pillars. First, metrics to measure health and performance. Next, logs to understand specific events and errors. And then, traces to follow requests end-to-end. All of this raw data then flows directly into a centralized observability platform. That platform stage is absolutely crucial because its entire purpose is correlating these completely disparate signals. During an active outage, the absolute last thing an SRE needs is to be rapidly context switching between 5 different browser tabs just to piece a puzzle together. Finally, this perfectly correlated data leads us to root cause analysis, empowering us to identify the impact and actually drive a resolution. The key benefits mapped out here, like faster incident detection, improved reliability, proactive operations, that's exactly why establishing this continuous pipeline is so incredibly vital.
We can beautifully deconstruct the investigation flow through these pillars: metrics for CPU, memory, latency, and errors, logs for app errors and security events, and traces for API flow and service dependencies. Let's break these down with a bit more technical rigor. Metrics indicate health. They're numerical measurements over time, things like CPU utilization, request latency, and error rates. Because they're just numbers, they are highly compressible and super cheap to store, making them perfect for triggering automated alerts. Logs detail the specific events. They're your detailed, time-stamped records. But be careful, logging everything is dangerous. Excessive log volumes will absolutely torch your cloud bills, so they have to be structured and targeted. Finally, traces map the end-to-end request flow. They are the absolute secret weapon of microservices. By utilizing distributed context propagation and unique span IDs, a trace acts like the glue holding a single user request together as it jumps across the network, from the front end through a dozen middle-tier containers, all the way down to the database.
Now for 4, the Observability toolchain. With the theoretical pillars firmly established, let's review the actual tooling landscape that makes all this possible.
There's a massive ecosystem of tools that engineers use to correlate and analyze all these signals. We've got Prometheus, Grafana, Loki, Tempo, OpenTelemetry, Datadog, New Relic. A critical standard that has completely changed the game recently is OpenTelemetry. It provides a unified, open-source framework to generate and export all 3 pillars of data. This is massive because it prevents vendor lock-in. You instrument your code exactly once, and you can send that data anywhere. On the open-source side, you have the heavyweights. Prometheus is heavily relied upon for capturing those metrics, while Grafana is the absolute industry standard for visualizing them. Loki handles log aggregation efficiently, and Tempo manages the distributed tracing. Alternatively, you have enterprise commercial solutions like Datadog and New Relic. These platforms offer comprehensive, out-of-the-box correlation without you having to stitch open-source projects together yourself, though, they definitely come at a premium enterprise cost. Ultimately, the specific tool you choose matters a lot less than ensuring your toolchain handles all 3 pillars cohesively.
Let's transition to 5, empowering SRE practices. Next, we really need to connect this tooling directly to operational outcomes and reducing downtime.
By moving through this incident response lifecycle, site reliability engineers use deep visibility to drastically reduce mean time to resolution. Step 1, detect incidents faster. Step 2, identify bottlenecks and user impact. Step 3, reduce MTTR. Let's put this into a real-world scenario, all right? Imagine it's Black Friday, highest traffic day of the year. Suddenly, a critical metric spikes on your dashboard. Checkout latency has just tripled. That's step 1, detect. Because your systems are highly observable, your SRE doesn't just panic. They immediately pivot to the distributed trace for the checkout API. The trace visualizes the entire request tree and highlights a massive red span deep in the stack. A third-party payment gateway is timing out. That is step 2, identify bottlenecks and user impact. Finally, the SRE clicks directly from that specific trace span into the exact log line associated with it, which reveals a specific TLS handshake error causing the timeout. Boom, that's step 3, reduce MTTR. Because of the pillars of observability, they bypass the database entirely, bypass the front end, and found the actual root cause in minutes instead of hours. This workflow is exactly how top-tier engineering teams survive.
Bring it home with 6, building your enterprise platform. Let's synthesize all these concepts into actionable recommendations for why you absolutely must invest in observability.
Our main takeaway here is clear. Invest in observability to reduce downtime, improve UX, and operate effectively. Without continuous visibility, your platform's reliability simply cannot be measured, managed, or improved. For technology leaders, platform engineers, and DevOps teams, investing in observability is not just some standard infrastructure upgrade, it's literally about buying back your engineering team's time and sanity. When you aren't spending 70% of your week manually grepping through disconnected log files on random servers just to put out fires, you can actually get back to building features. It shifts your entire engineering culture from an exhausting, reactive firefighting mode into a proactive, highly data-driven operation.
As you evaluate your own cloud-native architectures, I want you to leave this explainer asking yourself this single, uncompromising question. Can your platform detect problems before your users do? Let's be real. If your best monitoring tool is an angry user complaining on social media, or a sudden flood of furious support tickets, your observability strategy is failing. Instrumentation isn't something you can just bolt on as an afterthought. It is the absolute foundation of system reliability. Thanks so much for joining us for this explainer. Now go take a really hard look at your telemetry pipelines.